hard tissue ameloegenesis and hard tissue formation. Hard tissue formation is where at the site of future strip, the mitotic activity ceases and the IEE cells elongates and reverse polarity. The nuclei align with stratum intermedium, the Golgi complex facing dental papilla, and second cell junction upper Golgi complex separating differentiating ameloblasts into the cell body and an apical extension above the complex. And then there's ameloegenesis. Ameloegenesis has the pre-secretory stage where ameloblasts acquire phenotype and change polarity and develop protein synthesis apparatus. Then there's a secretory stage where the ameloblasts elaborate and organize through entire enamel thickness and highly ordered tissue. Then there's the maturation stage, which is the modulation and transport ions. Then the light microscopy of amelogenes is in region of cervical loop, low columnar cells, and the IEE and the OEE, stratum intermedium. In coronal region, cells are taller and columnar, and nuclei align at proximal ends adjacent to stratum intermedium, and then the cells secrete enamel initial layer, and the ameloblasts move away. Then the Tomes process formation. When formation of full thickness reaches ameloblast, enters maturation stage, ameloblast shortens. Stratum intermedium, stellate reticulum, outer enamel epithelium, which are the three recognized. Then there's the papillary layer formation and the reduced enamel epithelium. Then the ameloblasts stop modulating, reduce their size, assume a low cuboidal to flattened appearance. This flattened epithelium cover protects epithelium. In case of premature breakage, connective tissue cells come in contact with enamel and form cementum-like structure. Fluoride can be incorporated in enamel during this protective phase. REE ruptures, the tooth erupts. Electron microscopy of amelogenesis. There is a pre-secretory stage where the morphogenic phase, there is columnar cells, and then there's the Golgi apparatus and centrioles are located at the proximal end, and the mitochondria are dispersed throughout the cytoplasm, and the terminal bars are present. Then there's the pre-secretory stage. Then there's a differentiation phase in this, where the IEE differentiates into ameloblasts, elongate, and nuclei shift proximally towards stratum intermedium. Then the second junction complex is formed. Then the ameloblast body and Tombs process. Then there is the secretory stage, which is ribosomes, and the RER translate mRNA for enamel proteins. Then synthesized proteins are transported in its cisternae. Then the post-transitional modification in Golgi complex, packed into membrane-bounded secretory granules. Then the granules migrate into Tomes process. Then content of secretory granule is released against newly formed and mantle dentine. Rods and interrods are formed due to Tomes process. Tomes process is confined to two sites. One is the site where enamel proteins are released, where there is membrane foldings and rod enamel, and then there's B, the proximal site, the interrod enamel. Then distal Tomes process eventually squeezed out of existence, creating a narrow space which is filled by organic matrix, forms a rod sheath. Final few increments do not have rod as distal Tomes process is lost. Rod interrod layer becomes the prismatic, and rodless layer becomes the aprismatic. Then the prismatic enamel is sandwiched between the aprismatic and initial final layer. Then in the maturation stage, there's also the transitional phase, where there's a reduction in height of ameloblasts and decrease in their volume and decrease in organelle content. Then there's the maturation proper, where there's modulation and size growth, and smooth-ended and ruffle-ended. Smooth is 20%, ruffle 80%. Smooth, leaky, distal junction, tight proximal junctions, decreased endocytic activity, decreased lysosomes, and decreased calcium binding proteins. Then the ruffled is leaky proximal junctions, tight distal junctions, increased endocytic activity, increased lysosomes, increased calcium binding proteins, calcium deposited through it. And then Ameloblast secretory products such as the ameloegens, where the majority of developing enamel matrix are ameloegens secreted by ameloblasts. Ameloegens are rich in